Hey, what's up guys, Tanmay here for Simple Snippets, and this is a whole new tutorial series on fuzzy logic, fuzzy sets and concepts, as well as some numericals on fuzzy sets. So let's understand what exactly fuzzy logic and fuzzy sets are, and in this video tutorial we'll just discuss about the theoretical aspects of this topic. So here are the topics that we are going to address today. Okay, so first we'll understand what exactly is fuzzy logic. We'll see the binary logic versus fuzzy logic concept, and we'll see how member functions are associated with fuzzy logic. We'll understand the difference between crisp set and fuzzy set, and lastly we'll see a small representation of how fuzzy sets are actually denoted on paper. So what is fuzzy logic? So let's see a theoretical definition. As you can see on the screen, fuzzy logic is an approach to computing based on degree of truth rather than the usual true or value Boolean logic. So in usual Boolean algebra, we have only two values, that is true and false, or 0 and 1. But in fuzzy logic, we have multiple values based on degree of truth, or the degree to which a certain value is true or false. So I have drawn two diagrams. The first one is a case of traditional logic. So we have a person named Bob over here, and we have a question that is Bob honest, and we have two answers which are mutually exclusive, that is yes and no. So this is a binary logic concept wherein we only have two answers. This would represent 1 and this would represent 0. So this is the traditional or binary logic concept. Whereas below that we have another diagram wherein we again have Bob. We have the same question, is Bob honest? But we have multiple answers depending upon how honest he is. So we have extremely honest, wherein the value is 1. We have very honest, which is 0.8. We have honest at times, so that is 0.4. And we have extremely dishonest, 0.0. So in fuzzy logic, this is called as the degree of truth, and it can range from 0 to 1 and have multiple values. So this is the basic difference between fuzzy logic and binary logic. Now the applications of fuzzy logic are numerous. In real world scenarios, for example weather forecasting, business decision making, medicinal making, artificial intelligence and neural networks which are in trend today, then we have soft computing applications, electronics and telecommunications, robotics and so on and so forth. So fuzzy logic usually is used in all these fields and is gaining more and more popularity over the course of time. The reason why fuzzy logic applies so well in real life scenarios is because most of the scenarios we do not have a distinct value, but it is based on approximation. For example, the number of red blood cells in your blood cannot be actually counted, but we can always have an estimate value. Or the growth of bacteria in a particular environment can only be predicted, but we cannot have the correct value as well. So those are the applications, and moving ahead, fuzzy logic operates on the concept of membership and degree of membership, which I just said ranges from 0 to 1. So it depends on a membership function. Now this in this case, that is Bob honest, can be considered as a membership function with these as its different membership values. To understand that, let's see the difference between a crisp set and fuzzy set. So crisp set are usually classical sets which have distinct objects. For example, we have A, which is a set of fruits. So we have apples, oranges and mangoes. So this is a classical set or a crisp set. Another example would be B, which is a collection of even numbers. So we have 2, 4, 6, 8 and so on. Now each individual is called an entity or a member or an element of the set. Now fuzzy set is kind of different, wherein we have the degree of membership concept. So let me just write down a representation of a fuzzy set and I'll explain what it exactly is. So here's a fuzzy set which is given by, okay, so this is a basic representation of a fuzzy set. Now this numerator, it is not actually a numerator, but this upper value is known as the membership degree. That is the degree to which this lower value is associated with this set. So we can say that train has a degree of membership of 0.4 with this set. Car has a membership degree of 0.6 associated with set A. Cycle has a degree of membership of 0.7 associated with fuzzy set A. So the highest value of degree of membership is 1 and lowest is 0. So if we, for example, if we have 0 over here, it means that this element train is not associated with this set, or it is least associated with that set. And if it is 1, it means that it is strongly associated with this fuzzy set. So these are certain basics which you need to know about fuzzy logic and the representation of fuzzy set, and we'll see some operations as well which we will see in the next video tutorial. For example, certain operations which we apply on crisp sets, for example union, then we have intersection, then we have addition, and so on and so forth. So all those operations can be performed on fuzzy sets as well. So we'll see that in next video tutorial. Okay, so I hope you understood all these basic concepts, and this is just some theory which you need to know before solving some numericals, and in the next tutorial we'll see some numericals as well. So if you like this video and understood some of the concepts, you can give it a thumbs up and share it with your friends, and don't forget to subscribe to our channel. Peace.